Let's continue down the rabbit hole of working through picoCTF 2021 challenges. Today we are going to focus on encoding, challenge number 2. Welcome back to the channel, y'all. My name is Ari. If you're new here, I'm an author of 10 technical textbooks and I teach technical topics all around the world, from hardware to software. If that's something you're interested in, from hardware to hacking, click on the subscribe button and leave a like so we can continue creating content just like this for free for you. Alright, with all that being said, let's head over the keyboard and get started on challenge number 2. Alright. So Mod 26 is the name of the second challenge. The description goes, cryptography can be easy. Do you know what ROT13 is? Do you know what ROT13 is? Now, before we get to actually solving this challenge and discussing what this encoding ROT13 thing is, let's do what we normally do and we'll open up a terminal. I'm going to create a directory called Mod 26 and it's challenge 144. And then I'm going to cd into that directory. First thing we do inside of here is we open up a README file. And let's go ahead and describe this challenge. This challenge is called Mod 26. 26, let's copy the description and the content. So with that, we have a ugly string of characters, and it's telling us that we have to decrypt this ugly string of characters. The hint that it gives us is ROT13. ROT13 is a Caesar cipher. Caesar ciphers are the very basic level of encoding. What we do in a Caesar cipher is we take an alphabet, in our case we'll just take A through Z in the English language, and we pick a shift. A shift is a number of characters. Let's take, for example, we're trying to encode the word banana using the English language, all uppercase characters. And we pick the number 2, and we shift the word banana by 2 characters in the alphabet. Our banana, the word, becomes DCPCPA, which is very different from banana. And you wouldn't necessarily know how to decrypt this message if you didn't know the number of shifts. ROT13 just does this by 13. Today we're going to solve our challenge in 2 ways. One, we'll use an online tool and we'll get the flag pretty quickly. The second way that we'll do it is by using Python to implement a ROT13 decryption method on our own. Alright, so let's head over to the browser and take this ugly string of characters that the challenge is giving us. And let's go to the tool I like the most called CyberChef. You can search for it on DuckDuckGo or Google. And the way CyberChef works is we put our input in this input box and then we pick one of these recipes, and we can use all these different recipes built into the tool to change the output. In our case, we're doing ROT13, so we'll click on the encryption and encoding tab here, and we'll drag ROT13 right on over to the recipes, and we'll see that we have the flag right here. And we know it's a flag because in Pico, all the flags start with picoCTF and these squiggly brackets. So let's go ahead and copy that to the pasteboard, place it in the submission box and submit the flag and see if we're right. Awesome, we're correct. Alright, now that we've done it using CyberChef, let's head over to Python and create it on our own. First thing I'm going to do is I'm going to create a script using Vim. Vim is my editor of choice. And my script I'm going to call solve. First thing in a script like this, I'm going to put the shebang line. That means we can run it on the command line without having to type Python in front. Of course, you don't need to do this, but I enjoy doing it. Okay, so now let's go grab our flag, the one that we want to actually solve. We want to decrypt. And let's paste it in there. Now, all I'm doing is I'm storing that text in a variable that I'm calling flag. Now we're going to write this in a function. The way that you define a function in Python is you use the word def and then you type the Python name. So I'm going to call this decrypt. And to pass an argument to decrypt, I'm going to call this text. And for now, I'm just going to let it pass so that we can print out, we can run this script and print out what we get. So the way that we'll do that is I will say decoded is equal to decrypt, and I'm going to pass the flag variable. Then we're just going to print decoded. I'm going to open up a new tab here, and I'm going to change the solve script so that we can run it. The X stands for executable. So now I can just type solve, and we're going to get none as the output. And that's expected because we haven't actually returned anything yet. To solve ROT13, we need an alphabet that we're going to translate our letters to. In this case, I notice that we have lowercase letters and we have uppercase letters. And we have some characters in here that are not alphabetic, like the underscore and the quote. So we'll need to figure out what we're going to do with that. The first thing I'm going to do is I'm going to create two sets or two lists of the characters that we're going to use. First one is going to be uppercase characters. And now I'm going to create lowercase character alphabet. As we're walking through our text, we're going to look at each character. We're going to just look at each one. And we're going to say, okay, we want to shift this back by 13 characters. So let's do this for the first character, and then we can use that method to continue along and do the rest of the characters. Okay, so now let's go ahead and implement our decrypt function. That passes there just so that the file would run. If we didn't have it in there, we'd see an error. So instead of seeing that error, let's go ahead and change this. We are going to return back a string, or the answer, from this function. And I'm going to call that string answer. The first character that we're going to be working with is C. So in this example, we need to find the position that C is, lowercase c, in our alphabet. In our case, C is in the position of 2. And that's because Python is a zero-based language. So A would be at the 0th index, B the first, C the second, D, and so on and so forth. So how do we do that? Because we know it's in the lowercase alphabet here, it's just C, and we're just working with the first one. The first character itself here is going to be at the 0th index of our string. And in order to find the index of, or the position that that character is in, we can use the index function in Python. We know it's in the lowercase alphabet, so we can just call index on that. And now we know it's at the second position. Now all we have to do is add 13 to that and get the resulting character. I'll do this in one step. So now we've added 2 to 13, which will be our resulting character. And I am going to add this to our answer, and we'll run the function and see if we get a P. In Python, you can append a string by using the plus equals. Now let's head over to the script and run it. We should get a P, and we do. What if the character itself is not in the lowercase alphabet? What if it's in the uppercase alphabet? Well, let's handle that here. We're going to use a conditional. If first is in upper, then we are not going to do anything with it quite yet. Otherwise, if it's in the lower, then this will work. And if it's in neither, if it's one of these squiggly brackets or underscores or quotes, we just want to add it to the string. So we'll just use the answer plus equals result. This functionality that we did here is going to be pretty much the same for both upper and lower. Let's copy that over and change lower to upper. So now we can handle both uppercase characters and lowercase characters. All right, we're pretty much almost there. There is a point that we have to take care of here though. What if the second character is too many letters off of 13? Take our second character and notice the second character is V here, but if we add 13 to V, we're going to run out of room in our alphabet. To understand how we don't run out of characters in our alphabet, we'll need to understand the modulus operator. It sounds confusing, but it's pretty straightforward, and you probably actually already know it. I'm just going to describe it using a Python interpreter. So I'm going to open up Python here. Give an example. So let's say that we want to divide 15 by 5. What would the answer be? Well, 5 goes into 15 3 times, and there's no remainder. But what would the answer be if we divided 16 by 5? Well, in this case, 5 still goes into 16 3 times, but there's a remainder of 1 left over. So our modulus of 16 modulus 5, it would be 1. The modulus, all it's saying is give me the remainder, not the answer. So 16, the modulus operator is this percent sign. Modulus 5 is equal to 1. And that's because 5 times 3, the answer, plus 1 is going to be equal to 16. That's what the modulus operator does. Now, why is this important? Well, when we have our alphabet here, we're not actually interested in the 13th character out of V. We're interested in, well, how many times does this V go into the rest of the alphabet? We don't really actually care. We care about what happens on the other side, in the rotational side of our alphabet. So the way that we'll handle that is for each one of these bits of code, we don't want it to give us the 13th offset. We want to give it the 13th offset with a modulus of the length of our alphabet. And we can do that just like so. So now what we're saying here is we want to find the offset of the character plus 13, and we're not really interested in that character. We're interested to know that that character only goes until the end of our alphabet and wraps around if it's bigger. So now that we're dealing with the second character, let's run our script in Python again. And we'll see that we now have I, which is exactly what we want. We want PI for picoCTF. We're almost done. Stick with me here. So we've only been dealing with this character manually here, but let's actually run through all the characters. And the way that we can do that in Python is we can say for every single character in our text, let's run this function. And we'll use the for in syntax of Python. That is, for, we want a variable called ch. In text, we want to run all this functionality. So instead of first here, let's change this to ch. We'll change all the first, wherever the first shows up, as ch. And also, we're not actually adding the result, we're adding the ch here. All right, let's go ahead and delete first here, and we should be ready to go. Let's try it out. Look at that, very close. Looks like I made a typo because I assume this is next, not nay. So our alphabet, this needs to be X and this needs to be Y. Mistakes happen. Now let's try to run it and see if that is what we expect. All right, looks like we got the same result as the online tool did. Put this in our flag submission, and hooray, we got it. All right, congratulations. We solved this using both an online tool and we wrote our own solution in Python. Congratulations. I'll post all this code in the description below. If you liked this video and you learned something, hit the like button and leave a comment if something was confusing or you learned something new today. I read all these comments personally. In any case, happy hacking.